This screencast is on a U-Pack naming of branched alkanes. So in order to name these organic molecules, you're going to need to know your first 10 organic prefixes, and the tune of Farajaka can help you out with that. It goes like this: meth, eth, pro, but, meth, eth, pro, but, pent, hex, hept, octanodec, IU-Pack, IU-Pack. As you can see, my singing career didn't work out, but I do know how to name alkanes. So let's look at a first example. Let's say that each point here represents a carbon atom. So we have 1, 2, 3, 4 carbon atoms. And if we go back, 4 is bute. And so this would just be butane. Bute for 4 carbons, and the ane for all single bonds. So let's try a branched alkane. That's what we're here to learn about. Now, let's go ahead and highlight, like number 1 says, the longest continuous carbon chain. You can use a pencil, you can use a highlighter, but we have 1 carbon, 2 carbons, 3, 4, 5, 6. Now, let's try a different direction. What if we try this way? 1, 2, 3, 4, 5, 6. Well, we got to 6 in either direction, so I'm going to erase one of these. I'll get rid of this one and just keep the simplest one from left to right. And then I need to circle any groups. So I have this one group coming off of the main chain. Now, when I found that parent chain, I also needed to name it. It was 6 carbons long, so that's hexane for all single bonds. Now here I've got a 2 carbon group. Our prefix for 2 is eth, so this is ethyl. When we go to name those groups, they end in YL. For all of the alkyl groups are these carbon chain groups, so that will be ethyl. Now we need to number the chain to give the groups the lowest possible numbers. So in number 4, we'll number the chain. So we could have 1, 2, 3, 4 ethyl. Or let's try some other numbering. We could have 1, 2, 3, 4, 5, 6 if we number from the left. So going left to right, we'll have 4 ethyl. Right to left, we'll have 3 ethyl. We want to give the groups the lowest numbering. So we're going to pick the numbering direction from right to left, and we're going to get rid of the numbers we wrote in black. So then we'll have 3 ethyl. So it's 3-ethyl in a space and hexane. Let's try another example. Now we're going to look for step 1, the longest continuous carbon chain. We're going to draw a line through it with our pencil. This is the longest chain without picking up our pencil. So 1, 2, 3, 4, 5. So we get pentane left to right. We can also try another direction. We could try 1, 2, 3, 4, 5. That is still a 5 carbon chain. If you wanted to check just to be sure, you could try one more. 1, 2, 3, 4, 5. These are all 5 carbon chains. We're not finding a longer chain in any particular direction. So let's get rid of these and let's just stick with the orange main chain going from left to right, and then we'll circle any groups. So our 5 carbon chain, 1, 2, 3, 4, 5, is called pentane. We're going to have a 1 carbon group right here called methyl, and a 2 carbon group right here called ethyl. Now we'll want to number so the groups get the lowest possible numbers. Let's try left to right. 1, 2, 4, 5. Then our groups in red will be a 2 methyl and a 3 ethyl. Let's try right to left. I have 1, 2, 3, 4, 5. Now, right to left in black, there's a 3 and a 4 for our groups. So we're going to want the lowest possible numbers. We're going to want the number combination 2, 3 because it's lower than 3, 4. So let's get rid of these numbers and stick with the 2, 3. So then we have 2-methyl and 3-ethyl. The last thing we need to do is alphabetize these groups. We don't have any dis or tris yet, so we don't have to worry about that, but E does come before M. So we need the final name to be 3-ethyl dash 2-methyl, and it would have a space and then pentane. Or we can go to the next line for pentane. So notice that the 3 can come before the 2. The important part is that the groups are alphabetized. Ethyl before methyl. Let's try a couple more examples. Let's try one more that we need to name. We'll put some branches on this. Again, let's find the longest continuous carbon chain. So we'll go 1, 2, 3, 4, 5, 6, 7 for heptane. And it doesn't seem like adding any of those branches will help, so I'm not going to try those. I'm just going to stick with 7 is heptane. 1, 2, 3, 4, 5, 6, 7. For heptane, I'm going to circle the groups. Now, each one of these groups is a methyl group. All 3 of them are single 1-carbon groups. And instead of writing methyl a whole bunch of times, we're actually going to write tri for 3 methyl groups. So you can use the prefixes di, tri, and tetra. And then you can start using the organic prefixes, penta, hexa, hepta, if you have more of the same group. So we're going to do trimethyl. We just need to get our numbering. Let's try left to right. 1, 2, 3, 4, 5, 6, 7. Now at this point, we're going to have a 3 and another 3 and a 4 for our methyls. We're going to have 3, 3, and 4. Numbering left to right. Now let's try right to left. 1, 2, 3, 4, 5, 6, 7. In red, we'll have a 4 and 2 5s. We'll actually have 4, 4, 5. We want the lowest possible numbers, so we want the 3, 3, 4. So let's go ahead and get rid of the higher numbers and keep the 3, 3, 4. So our final name looks like this: 3, 3, 4 dash tri methyl, and then a space, and then heptane. So we're saying there are 3 of the 1-carbon groups on a 7-carbon chain. Where are those 3 located? Those 3 groups are located, 2 of them at carbon 3 and 1 at 4. So we always have to tell the number of every single group, even if it's a repeated number, even if it's 2,2-dimethyl or 3,3,4-trimethyl or 3,3,4,4-tetramethyl. We have to go ahead and tell where every single group is. Now, what if we are given a name and we need to draw out the structure? Let's say we're given a name 2,3-dimethyl-octane, and we are asked to give the structure. Start in a similar manner with the longest continuous parent chain. Start with octane. We're really starting with that longest chain. So go ahead and draw that out. 1, 2, 3, 4, 5, 6, 7, 8. Then go to carbon 2, carbon 1, 2, and put a methyl group. Go to carbon 3 and put a methyl group. When I'm the one responsible for drawing them, I always draw my main chain just straight across for my longest carbon chain, and then I always put my groups left to right just because that's easiest for me. I might as well lay it out in a way that's easy for me. Let's try another one. Let's try 4 propyl space, and this is decane. So dec means 10 carbons in that main parent chain. 1, 2, 3, 4, 6, 7, 8, 9, 10. I go to carbon 1, 2, 3, 4, and I put a 3 carbon group. So that carbon group is going to look like this: 1, 2, and 3. And you can check to make sure that there's not a longer carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But sure enough, 10 is the longest continuous carbon chain, and it would have a 3 carbon group coming off of it. So that's how to name or draw the formulas of branched alkanes.